In this example, we're going to compare F1 and F2 when we have some sort of difference in angle as well as length. So we know that our current, whatever the value is, it doesn't matter, but we're just going to say that we have I1 for our first current. And given what's written in the question, the current in the conductor is doubled. So I2 is going to be equal to 2I1. So we're setting ourselves up for some sort of like rate proportion type of question. We have some sort of length, L1, and the length of the conductor in the second one is doubled. So that leaves us with L2 equals 2L1. We have two different angles. It's rotated starting at theta 1, which is 90 degrees, and ending at theta 2, which is 60 degrees. And we're going to assume here that our beta value is constant throughout. Now, it doesn't matter what value we put here, and you'll see why, because we'll be able to start canceling some stuff out in a second. So we're comparing F2 to F1. So F2 is equal to, these are going to be fractions in just a second, so these are numerators of the fractions, some beta value times the second current times the second length times sine of the second angle, comparing that to F1, which is the same beta value, I1, L1, sine theta 1. So now that we have this, we can actually do more than we think because we're going to sub in to these values here, and we're going to end up canceling our values for beta. So F2 over F1 is equal to no more beta values. We know that I2 is 2 I1, L2 is 2 L1, sine of 45 over I2, sorry, I1, L1, sine 90. This then allows us to cancel a little bit more. So let's take a look at what we're left with. F2 over F1 is equal to 4 sine 45 over sine 90. This, after a little bit more of manipulation, gives us F2 equal to 3.46 F1. So how much stronger is a new force? The new force is 3.46 times stronger than the old force after we double the length, double the current, and change the angle from 90 to 60.